Okay, let's go ahead and go over the drawing atomic models activity. So we're going to start with hydrogen, and I've got to get my pen set up here. So let me see if I can do that. Smart board is not being very smart right now. So, okay, let's go ahead and look at hydrogen. Now we know hydrogen's atomic symbol is H, the atomic number is 1, and the mass is like 1.01. Okay, so the nucleus is going to inside have protons and neutrons, but we only want to put in what this particular atom has. If the atomic number of hydrogen is 1, then we know it has 1 proton. The number of neutrons is equal to the mass minus the atomic mass. In this case, it's 0. So there are no neutrons in hydrogen. The number of electrons are always equal to the number of protons, since we're working with atoms here. So as a result, there's only 1 electron in hydrogen. Okay? Let's move on to nitrogen. Nitrogen's atomic symbol is N, its atomic number is 7, and the atomic mass is 14. So that'll help us to draw the nucleus, because we know that there are 7 protons, and the number of neutrons, again, is 14 minus 7 to give us 7 neutrons. If there's 7 protons, that means there must be 7 electrons. The first 2 electrons go in the first shell, so we can put 2 there. So the first electron shell always holds 2. That means we need to fit in 5 more in the second shell. So there's 1, 2, 3, 4, 5. Okay, so that's how nitrogen would look. Notice the number of valent electrons for nitrogen is 5. There's 5 in that outside shell. Okay, how about sodium? So let's do sodium. Sodium's symbol is Na. The atomic number is 11, and the atomic mass is 23. Okay, so right off the bat, we know atomic number, 11 protons. Now, as far as the number of neutrons, that's equal to the mass minus the atomic number. So 23 minus 11 will give us 12 neutrons. So notice they're different. They're not always going to be the same. Well, if we have 11 protons, then that means we must have 11 electrons, since we're working with an atom here. So we can put 2 in the first shell. We can fit as many as 8 in that second. So that gives us a total of 10, but we need one more. So we can go ahead and add one more electron on the outside. So notice valent electrons here now equals 1. Okay, so there's 1 valent electron. Now sodium is one of the unique elements that can become an ion. And what we mean by that is sodium is not very happy with its state. It's got a lot of empty holes in its valence electron shell. So it wants to either fill up its valence electron shell with 7 more electrons, or in this case, it could actually just lose an electron, which would make it positive. So that's why sodium can become a positive ion. So that's we'll talk about sodium ions later, and also why they form ionic bonds. Okay, now let's look at carbon. We actually did carbon in class, so I'm not going to go into much detail about that. But again, the atomic number means there's 6 protons. It's going to be 6 neutrons. And that means we also have 6 electrons. 2 in the first shell. We need 4 more to go in that second shell. Carbon is a very unique element, and we're going to look at this fact tomorrow in class. There's actually 4 empty spots, which means that carbon can form 4 covalent bonds. if we look at nitrogen, there's 3 empty spots in the valence shell. There's 5 electrons. It could fit 3 more, so it could do 3 covalent bonds. So nitrogen is important too. But carbon is real special because it can form 4 covalent bonds. Well, let's do oxygen. Oxygen's atomic symbol is O. The atomic number is 8. The atomic mass is 16. It rounds to 16. So that means in the nucleus we've got 8 protons. And then we also have 8 neutrons. 16 minus 8 gives us 8. In the first electron shell, we've got 2 electrons, but we need 6 more to give us 8. So we got 1, 2, 3, 4, 5, 6. Notice oxygen could give us 2 covalent bonds, which is why oxygen will bind with 2 hydrogens. 2 hydrogens will come over and fill up these gaps here to give us water, H2O. Again, we'll talk about that more later when we look at compounds. Let's move on to phosphorus. Phosphorus is a little bit bigger. So phosphorus atomic symbol is P. Atomic number is 15. The atomic mass is 31. Okay, so let's take a look at phosphorus. The nucleus is going to have 15 protons. 31 minus 15 is 16. So notice this is another weird atom. Has 16 neutrons. Okay, so we need a total of 15 electrons. So let's start by putting 2 on the first shell. And then we'll do 8 in the second. So that's a total of 10. We need 5 more. So we add a third energy level or third shell. We got 1, 2, 3, 4, 5. So notice phosphorus, like nitrogen, has 5 valence electrons. So phosphorus and nitrogen, if you notice, they're right in the same column of the periodic table. Because of that, they have 5 valent electrons, which means they can form 3 covalent bonds. So both nitrogen and phosphorus are pretty special in that regard, in being able to form 3 bonds with other elements. Carbon is the one that really takes the cake, though, being able to form 4 covalent bonds. It's lightweight, and that's why we find carbon is the backbone for important organic molecules like sugars or carbohydrates. They've got a lot of carbon in them. Now there's a few more to draw on the next page. So I'm going to clear that, and I'm going to scroll down, and I want to go over just a couple more. All right, and let me reset this so that I can draw again. All right, we're going to do sulfur now. Sulfur's atomic symbol is S. Its atomic number is 16. And it's 32 is the atomic mass. So when we look at the nucleus, we've got 16 protons and 16 neutrons. Notice if you look in your periodic table, sulfur is right under oxygen. So it's in the same group as oxygen. So it should have 6 valent electrons. Let's see if that works out. We got 2 in the first shell. We're going to fit 8 in the second. So that's a total of 10. So that leaves us 6. And that outside. So yes, indeed, sulfur, just like oxygen, has a total number of valence electrons of 6. And again, valence electrons, number of electrons in the outside shell. All right, potassium is an interesting one. Potassium's atomic symbol is K. And we got 19 for the mass and 39 for the, or 19 for the number, 39 for the mass. So potassium's a little bit bigger, so I'm going to give myself some extra room here. So we got 19 protons, 20 neutrons. We need 19 electrons. That's a lot. So there's 2 in that first shell. How am I going to put in the second? You got it. I'm going to put 8. All right, that's 10. All right. All right, I can add 8 more in this level. So that's 18, but I need 19 more. So guess what? Potassium is going to have how many valence electrons? 1. 1 valent electron. So potassium is very much like hydrogen with 1, and also like sodium, which means potassium, like sodium, can become an ion. If that electron is lost, it can become the potassium positive ion. Calcium is right next to potassium. Calcium is right next to potassium in the periodic table. Atomic number 20, and atomic mass of 40. Let's take a look at calcium. So we got 20 protons, 20 neutrons. Again, 40 minus 20 would give us 20 neutrons. That means we need 20 electrons. Ignore the announcements. You can tell it's the end of the day for me. Okay. There's 8 more. So that's 10. So there is 18. So we need 2 more. So we're going to add an extra shell along the outside to give us our 2 extra valent electrons. So again, valent electrons for this one, 2. But calcium, just like the others, can lose those 2 electrons. They can go away. If it loses 2 negative electrons, that means calcium can become an ion too, and it's the calcium 2 plus ion. It's got 2 positive charges to it. So again, that's just looking at ions and again drawing atomic models, and I hope this helps for you and gives you a visual to see. Tomorrow we're gonna go over the molecules, and I can do some more demonstrations on that. But I just wanted for now just to go over the actual atomic models themselves.